Good morning, everyone, and welcome to the September 2023 edition of the Southeast Monthly Climate Webinar, where we talk about the climate and special topics pertaining to the Southeast region. My name is Chris Fuhrmann. I'm the regional climatologist with NOAA's Southeast Regional Climate Center, and I'll be giving a climate overview of the past month. Our other speakers today are Jeff Dobur from the Southeast River Forecast Center, who will provide a water resources update, Dave Zierden from the Florida Climate Center, who's filling in this month for Pam Knox and will provide an agricultural impacts update. And this morning, we're pleased to have Dr. Megan Johnson from the U.S. Forest Service, who will be discussing climate-driven changes in prescribed fire in the Southeast U.S. So again, thank you all for joining us. Just a reminder to type your questions and comments into the question box at any time, and they'll be answered at the end. Also, a recap email of this webinar will be sent out with a YouTube link to this recording in the next few days. All right, so let's get started with an overview of the climate. So over the past month, we continued to see above, and in some cases much above average temperatures across a good portion of the region. The greatest temperature departures were observed across northern and eastern sections of Virginia and North Carolina, as well as southern portions of Georgia and Alabama. Back on August 26th, Mobile, Alabama recorded a maximum temperature of 106 degrees, making it the warmest temperature observed in a record going back to 1872. We also saw significant temperature departures across Puerto Rico and the U.S. Virgin Islands. On August the 24th, San Juan tied its warmest daily mean temperature of 89 degrees in a record going back to 1898. As we suspected last time, a number of locations ended up recording their warmest month on record back in August. And combined with the record warmth we saw back in July, many locations ended up recording their warmest summer on record. And we'll look at that more closely on the next slide. In contrast, temperatures over the past month were actually a bit below average across much of Tennessee and central and eastern portions of Georgia and the Carolinas. All right, next slide. As we mentioned last time, it's been a tale of two temperature patterns this summer across the region. The map here shows the rankings of mean summer temperatures across the region, including Puerto Rico and the U.S. Virgin Islands. You'll notice a lot of maroon across Florida, southern portions of Alabama and Georgia and the Caribbean, where numerous locations recorded their warmest or tied their warmest summer on record. Some of these include Mobile, Alabama, Brunswick, Georgia, Key West, Florida, Miami, Pensacola, Sarasota, and San Juan, Puerto Rico. Many other locations shown in red ranked in the top 5 warmest summers on record. The warmth across Florida was especially noteworthy and was reflected in the state average data, with the mean summer temperature across the state ranking as the second warmest on record since 1895. On the other hand, temperatures across the rest of the region were near average to even below average for the summer. Places like Concord, North Carolina, near Charlotte, and Chatham, Virginia, in the central part of the state, both of which have nearly 100 years worth of data, recorded one of their coldest summers on record. A few other locations across the upstate of South Carolina and western portions of North Carolina and Virginia also recorded below average temperatures this summer. Okay, next slide. Turning our attention to precipitation, we see that much of the region was drier than average over the past month, except in places that were affected by tropical cyclones. A swath of 5 to 10 inches of rain with some locally heavier amounts fell across the Big Bend region of Florida and along southeastern portions of Georgia and the Carolinas from Hurricane Idalia on the 30th and 31st of August. More heavy rain fell just this past weekend across eastern sections of North Carolina and Virginia from Tropical Storm Ophelia. On the other hand, rainfall deficits continued to build across parts of Puerto Rico and especially across the U.S. Virgin Islands, where some locations are on track to record their driest year on record. In particular, places like St. Thomas and St. Croix have only received about half of their expected precipitation so far this year. Okay, next slide. So not long after our last webinar, we saw Hurricane Idalia make landfall along the Big Bend region of Florida on the morning of August 30th. Idalia made landfall as a strong Category 3 storm with winds of 125 miles an hour, making it the strongest hurricane to strike this part of Florida in over 100 years. Storm surge reached 8 feet in the area around Cedar Key and as much as 3 feet around Tampa Bay. The surge was exacerbated by both the high tide and the blue supermoon. As Idalia tracked inland during the day on the 30th, it weakened to a Category 1 while over southeast Georgia, as shown in the satellite image here on the left side. Later, it crossed into eastern South Carolina and weakened to a tropical storm. Along the way, Idalia produced locally heavy rainfall, high winds, and about a dozen tornadoes across eastern portions of Georgia and the Carolinas. As the storm emerged in the Atlantic Ocean, it produced 2 to 4 feet of additional storm surge along the Carolina coastline, resulting in significant flooding in places like Charleston and Edisto Beach in South Carolina. Further inland, heavy rainfall produced localized flooding, forced some roadways and highways to shut down, and several rivers to crest to at least moderate flood stage. Hundreds of thousands of power outages were reported across Florida and southern Georgia, while tens of thousands of power outages were reported across eastern sections of the Carolinas. Estimated insured losses are currently around $2 to $5 billion. Of course, that might change. And at least 4 deaths so far have been confirmed. And just this past weekend, parts of North Carolina and eastern Virginia were impacted by Tropical Storm Ophelia, shown here on the right, which made landfall near Emerald Isle, North Carolina, early on Saturday morning with winds around 70 miles an hour. Though a tropical storm, some hurricane force gusts were reported near Wrightsville Beach, North Carolina, and along parts of the Outer Banks. Wind gusts of 40 to 50 miles an hour were also reported across central portions of North Carolina and Virginia. Rainfall totals over the weekend were generally between 3 and 6 inches, although some CoCoRaHS gauges in eastern North Carolina recorded over 9 inches of rain. Okay, next slide. Looking at the Drought Monitor, we see an expansion and intensification of drought in a few places due to continued heat and lack of rain. Abnormal dryness expanded across Alabama, parts of southern Tennessee, eastern Virginia, and pockets of central Georgia and northern Florida. Moderate drought emerged across the western panhandle of Florida and extreme southwest Georgia, while severe and extreme drought emerged across parts of southern Alabama. Moderate drought expanded across northern Virginia, and there's now a swath of severe drought extending through the Shenandoah Valley. On the other hand, Idalia alleviated some dryness across eastern portions of the Carolinas, while areas of moderate to extreme drought contracted a bit along the west coast of Florida. Okay, next slide. Looking in the Caribbean, we see a 1-category improvement from severe to moderate drought across northwest Puerto Rico, with abnormal dryness expanding along the northern coast as well as the outlying islands. Drought conditions continue to worsen on the U.S. Virgin Islands. Exceptional drought is now found on both St. Thomas and St. Croix, where record warm temperatures, high winds, and well below average rainfall have led to significant moisture deficits and impacts on these islands. Okay, next slide. Okay, turning to ENSO, the September update from the Climate Prediction Center indicates slightly increased confidence, now up to a 71% chance of a strong El Nino event by this winter. This is based on observed and forecasted sea surface temperature anomalies and a more robust coupling of the ocean and atmosphere. These conditions are reflected in current observations as well as greater forecast confidence as seen in the model projections there to the right. It's also worth noting again that the chance of a very strong El Nino, one on par with some of the biggest events of the past 75 years, is now around 30%. Okay, next slide. All right, so looking ahead over the next 3 months, the Climate Prediction Center is forecasting above average temperatures across Florida and along the northern Gulf and Atlantic coasts, while precipitation is projected to be above average for virtually the entire region. Okay, next slide. If we look across the Caribbean, we see the multi-model ensemble continues to forecast above average temperatures and above average precipitation over the next 3 months. Okay, next slide. And these seasonal projections are largely reflected in the Drought Outlook, where drought removal remains likely across northern Florida as well as, across northern Virginia as well as Florida and Puerto Rico, while some improvement is expected across southern Alabama and the U.S. Virgin Islands by the end of the year. No new development is expected. All right, next slide. So for the next 6 to 10 days, as we turn the calendar to October, we see a generally warm and dry pattern as temperatures are expected to be above average for nearly all the region, except in the extreme eastern Carolinas, while precipitation is leaning below average across a good portion of the interior of the region. Next slide. And this pattern is more or less reflected in the 7-day QPF. This is from yesterday evening, where most interior locations may see less than 1/4 inch of rain, while parts of the Florida Peninsula may see up to 5 inches of rain over the next week. Okay, next slide. The National Hurricane Center continues to monitor Tropical Storm Philippe and a tropical wave located just west-southwest of the Cabo Verde Islands. This image here is from the 8 p.m. Update last night, but there's been little change over the past 12 hours. Philippe is expected to begin tracking to the northwest over the next several days, though is not expected to strengthen. But its remnants may bring some rain to Puerto Rico and the Virgin Islands by the weekend or early next week. On the other hand, the cluster of showers and thunderstorms associated with the tropical wave that's currently in the eastern part of the basin is expected to develop into a tropical depression over the next few days. Okay, next slide. Looking out to 2 weeks to the first full week of October, we see a continuation of warm weather across the region, while precipitation is forecasted to remain below average across much of Tennessee and Virginia. Okay, next slide. And if we look out 3 to 4 weeks to mid-October, we see above average temperatures persisting across the southern half of the region with equal chances of above or below precipitation everywhere, except for maybe extreme northern Virginia, which is leaning slightly wetter than average. Okay, next slide. Just real quick, lastly, it's that time of year where we start to pay attention to the fall foliage. In fact, here in Chapel Hill, I'm already starting to see some red on a few maple trees in my neighborhood. On average, much of the interior of the region will be at or just past peak color by the end of October. Earlier this month, AccuWeather released its fall foliage forecast for the country, and it shows typical conditions across much of the southeast, with the most vibrant colors in extreme northwestern Virginia. On the other hand, hot and dry weather over the past several months, as well as the possibility of some colder air over the next several weeks, may lead to duller colors and earlier leaf fall across western parts of Alabama and Tennessee. Okay, next slide. And with that, just as a reminder, we have a number of fall foliage resources for you on our website, SERCC.com. So check those out, especially if you're planning a trip and want to check on the most up-to-date conditions. Next slide. All right, so thank you very much for your attention. There's the summary for you to look over after the webinar. And with that, I'll turn it over to Jeff for our water resources update.
Hi, Jeff. I don't think we can hear you. Jeff, we still can't hear you for some reason. Okay, so apologies for this technical difficulties. Jeff, we are not able to hear you, even though we were able to hear you in the test. If not, perhaps, oh, here you are. Thank you.
Can you hear me now? Okay, sorry, Meredith. I think our network's going in and out here. Sorry about that. Can you hear me now?
Yep, perfectly. Thanks.
Okay. So thanks, Meredith, and thanks, Chris, for giving that meteorological rundown. And I'm just going to quickly go through the stream flows here, and hopefully we won't cut out anymore. But you can see on the map to the left there, most areas near normal as far as stream flows represented by the green dots there. We do have some pockets of below normal flows within some of the smaller coastal rivers in South Alabama and the Florida Panhandle, and then some above normal flows in the coastal Carolinas and the coastal Georgia from the past couple of tropical season systems, as Chris highlighted earlier. But overall, we're seeing the 28-day runoff stream flow graph there on the right. We continue to stay in the green normal range, which has been common, as you can see, the past couple of years. We'll go on to the next slide. We'll break it down state by state. Staying in the normal range is also a common theme for the individual states there across Alabama, Georgia, and Florida. Alabama, we did see a recent dip into the below normal range, and Georgia, a recent rise into the above normal range. But on average, again, for the most part, hovering in or close to that normal range. Going to the next slide, we'll move east into the Carolinas. And again, for the most part, stream flows on average in all three states hovering near or close to that normal range, that green range there. We'll go on to the next slide. And as far as current river impact conditions, we have some isolated river flooding in the Florida Peninsula on the Peace River in DeSoto County, with several other rivers near Bankful in that area. And this is an area we'll be watching this week for additional isolated flooding with the potential of some localized heavy rainfall, especially in some smaller headwater basins. Going to the next slide. As far as river flooding, it was what is typical this time of year. We see we are in week 39. And this time of year, we can be active, as you know, with the tropical season, but not so much so far for this year. So we'll keep our fingers crossed that we can continue to get those storms to stay away or just bring beneficial rainfall to the region. Next slide. When we look closer at the river flood climatology for just Central and South Florida, we see that this is typically the peak, mainly due to tropical systems, but also this time of year, we get these stalled fronts across the Florida Peninsula, as we see now. And these can sort of act as a focus for continuous chances of locally heavy rainfall over a several-day period, as we are seeing in the situation right now for this week. So this won't be surprising to see some additional minor flood impacts across Central and South Florida this week. We also see, though, climatologically speaking, that by mid-October, that's in a few weeks of time, the climatology tells us our chances for flooding begins to diminish in that area. Next slide. So this ties in with our tropical storm climatology. Most of us are familiar with the Atlantic Basin climatology, but when we look at the past history of just the southeast storms by region for each week of the year, we see the same signal here. Generally, by mid-October, history tells us tropical activity begins to become less evident across the southeast region. Next slide. So as we pointed out, this is a low flow time of year for the southeast. And this is not unique really to most of the eastern half of the U.S., as you can see there on the map. And so for our next slide here, for our prediction for October and November, let's continue to expect stream flows to remain in the near normal range. And this is still sort of staying with our current observations and trends. But if we go on to the next slide, as we move into December, the El Nino conditions that Chris mentioned earlier are likely to begin to increase rainfall across the southeast. And these analogs, these stream flow analogs you see here, show that there is a greater chance for above normal stream flows in many of the southeast river systems. Of course, this isn't always 100%. You can see on the pie charts, not 100%, but the best chances are we see a wet December and above average stream flow. And that is why, for the next slide, we expect stream flows for December to increase more than they typically increase for that time of year, with that wet weather expected, increasing the potential for river flooding. I guess, again, this isn't 100%, as there sometimes are other factors in the global weather system that can affect, but El Nino is usually a pretty strong influencer, as Chris has mentioned in this presentation as well as in the past. Pretty good strong influencer for the southeast for most years. And so for now, we see river flows probably flowing pretty good heading into 2024. So that's our stream flow and water resources update. I will go ahead and pass it over to David for the agricultural.
All right, thank you very much, Jeff. Yeah, and I'm pinch hitting today for Pam Knox, but she did put together most of this information, so I'm mostly just presenting it for her. So we'll go ahead and get started. One comment, Chris mentioned statewide average temperature for the state of Florida, that we ranked second warmest on record for this summer season as a whole. However, in July, we broke the record for the warmest month ever at 84.2 degrees average temperature. And then in August, we actually absolutely crushed that at 85.0. So we set new state records for highest monthly temperature ever in both July and August. So with that, we'll go ahead and look at agricultural conditions. Recent drier conditions, especially in the Florida Panhandle, southern Alabama, southwest Georgia, have put stress on crops that need moisture to reach harvest stage. However, cooler temperatures are slowing development. because of heavy rainfall in April and then again in early June, some fields were planted quite late this year, and they're really struggling to accumulate enough growing degree days to finish the crops with peanuts, cotton, other row crops. So we're looking at that closely. Again, some peanuts are being harvested, but because we're running out of growing degree days and they're not maturing any further. There's been an excess of fungal diseases across the Southeast with the high humidity we've experienced this summer. White mold is shown on the left, and brown spot on soybeans has been fairly prevalent. Pasture conditions have improved, but some farmers are still feeding supplemental hay due to poor conditions. And there's also worry that with the onset of dry weather, they might miss their third cutting of the year, which would really tide them over into the winter season. Summer vegetables are just about over with now. Those fields are now getting ready for winter grains and cover crops. We'll talk more about Hurricane Idalia and the severe damage to infrastructure, pecans, vegetables in both the states of Florida and Alabama and Georgia. And we even had some information on Tropical Storm Ophelia and the damage it did in North Carolina and Virginia. So with that, we'll go to the next slide. We'll take a quick look at soil temperature and moisture conditions across the Southeast United States. Similar to the temperature slides that Chris showed, we see below normal soil temperatures across northern Alabama, Tennessee into Kentucky, yet above normal soil temperatures across the northern Gulf Coast and the state of Florida. Over on the right, looking at soil moisture at 20 centimeters, we see pockets of dryness across the Florida Panhandle, central Alabama and western Mississippi, but otherwise closer to normal, even above normal in south and central Florida. Things are a little drier at deeper soil levels, 100 centimeters, due to the heat we've experienced over the entire summer. On the next slide, we'll start talking about Hurricane Idalia and its impacts. Estimates are all over the map, anywhere from $80 million to $370 million in agricultural damages. Surveys are still coming in. Overall, with damage from storm surge and to structures, this did turn out to be $1 billion disaster. One of the big agriculture impacts was to the poultry industry in the Suwannee Valley. Loss of an estimated 5 million chickens due to damage to the structures themselves, and also just the loss of power and the inability to ventilate properly caused a lot of mortality in the poultry industry. In addition to crop loss, there was tremendous infrastructure loss in agriculture. Center pivots all over the Big Bend were knocked over and damaged from the winds. Sheds, structures, equipment were all damaged by high winds. And also very critical, 2 peanut buying points were severely damaged, which will really cause problems for growers trying to get their product to the market. On the next slide, we'll talk a little bit more about Idalia's impact on Georgia agriculture. The pecan industry took significant losses. Pecan trees are fairly fragile to begin with and are really susceptible to wind damage. Here we see some blown over, others with significant loss of branches and the immature nuts being blown off. Also, heavy damages to vegetable crops and harvestable fruit, damage to the structures that protect these vegetable crops. Cotton also suffered damage, being twisted and shaken and losing bolls from the wind. It's not clear if this crop will recover. So we'll go on to the next slide. Is it too early to think about frost damage? Well, As we get into October, there is a 10% chance of an early frost across the higher altitudes and the more northern locations in northwest Georgia, Tennessee, the Western Carolinas. However, if we look at the first freeze at the 50% probability, most of the area will expect their first freeze at sometime in November, from early November in the more northern areas, mid-November through central Georgia and Alabama, and later in November for southern Georgia and the Florida Panhandle. So we'll go to the next slide. This is our summary slide. I do have some impacts of Ophelia in North Carolina and Virginia. The main crops affected were tobacco and sweet potatoes with their broad leaves. A lot of wind damage to these crops. Other crops seeing damage: soybeans, corn, cotton, peanuts. And again, the same old story, poultry industry with just the loss of power and the inability to ventilate these poultry houses resulted in a lot of morbidity to the chickens and other poultry there. One last comment. I drove down I-10 last week and I saw really significant damage to some late planted cornfields, lots of center pivots that were overturned, and also a good amount of timber damage where the core of the winds traversed through the Big Bend and up into Georgia. So other than that, here's the summary, and I'll turn it over to Megan Johnson with the U.S. Forest Service to talk about climate change and prescribed fire.
Great, thanks for having me. Let me switch over to me getting to drive my slides. All right, let me know if you're not seeing this okay, but thanks for having me. As Chris said, I am currently a postdoc working with the Forest Service through ORISE, but the research I'm going to talk to you about today is something I did while I was at North Carolina State University in Raleigh, and has to do with climate-driven changes to prescribed fire in the Southeast. And my background is in engineering and atmospheric science, but I'm really coming at this from an air quality perspective. And so I didn't do, the climate work on this, so I'm definitely going to take some time to tell you a little bit about that, though it is not my work. But just to give you an idea of where I'm coming from, my dissertation was focused on smoke, and we care about smoke because it's a major source of air pollution. In this case, what we're really thinking about is what we call PM 2.5, or fine particulate air pollution. We care about this because it impacts human health. And when we think about the Southeast, the main fire smoke source is prescribed fire. We use this extensively in the Southeast to meet a lot of really important management objectives. But when we also think about the Southeast, the population could be potentially more at risk here. We know that we have one of the largest populations that live in what we call the wildland-urban interface, or the WUI, and this is where you may be more at a higher risk of experiencing fire danger. And on top of that, population living in the Southeast might also be more vulnerable to health impacts from smoke due to various socioeconomic factors. And then on top of all this, the whole reason we're kind of here and talking about this is climate change. Climate change is going to impact fire across the world, but here in the Southeast as well. This is going to be a big deal because it could potentially restrict how often we can use prescribed fire, and it's also going to have an impact on how much wildfire smoke we're experiencing in the region. So that's what I'm going to kind of focus on today. And this really came from a paper that came out. My interest in this came from a paper that came out in 2020, where they analyzed projected climate conditions in the Southeast and how this could affect prescribed fire, and they found that we're likely going to have fewer good burning days in the future. When I read this paper, like I said, coming from my stance on background in air quality and engineering, I asked myself, how is this going to affect smoke in the region? And on top of this, the meteorological factors are one piece of this, but how are burners going to respond to fewer good burning days in the future? Because not necessarily all the good burning days are used right now. And thinking again about the burners and climate in the future, are they concerned about climate change impacting their practice? And what do they need to be prepared for potentially fewer days in the future? So just to kind of run down again what I'm going to tell you about today, I'm going to give you a little bit more of a background on what prescribed fire is like in the Southeast in case you're not necessarily familiar with that. So that'll be kind of like a why we use it, who uses it, when and where. And then I'll go, like I said, into a little bit more detail on the kind of the climate piece of this that I used for my own research, which is not necessarily my research, but to talk about how we got to the point where we figured out that climate change is likely going to reduce our burning opportunities. I'm not going to focus as much on wildfire just due to time, but you can always ask me those questions later if you want. And then the last two pieces will be where I'm kind of giving you an overview of the research that I did based on these climate projections related to burner concerns. We did a survey asking what they're worried about, what they need, and what they might do if faced with fewer burning opportunities in the future. And then we also used this in a modeling scenario to look at what could happen to smoke in the region. So jumping right into this kind of background primer on fire and prescribed fire and getting into some of the climate projections here. So like I said, prescribed fire is used very frequently in the Southeast. It's used more frequently than in any other region in the country. And this is, a use of controlled fire to meet various management objectives. Most frequently in the Southeast, this means we're using this to manage habitat for wildlife. We're using this to manage different plant species, especially under the Endangered Species Act. And we're also using this to reduce hazardous fuel loads that could lead to a wildfire. But this is a challenging thing to use because you are using fire. You've got to be safe. And so there are definitely acceptable conditions under which you can use it. A lot of that has to do with the weather and climate conditions, kind of leading up to what's happening with the fuels on the ground. And another big piece of this is smoke management. We don't want to be, impacting health, and we definitely don't want to be impacting safety in the form of visibility for planes, for trucks, things like that. And so this is kind of from our survey, but just to tell you a little bit more about who is using fire in the Southeast. Most of this happens on private land, secondarily on state lands, but that's also, just reflective of the land types in the Southeast. It makes sense. And when we asked how often folks are burning in the Southeast, we have an interesting split here. There's a big camp of folks who are maybe burning more than 10 times a year. There's also a similarly large group of folks who are burning on average less than 5 times a year. So this is used by a lot of different folks in a lot of different situations. And so their needs are going to change depending on how much and how frequently and for what purpose they're using fire. And so, like I said, looking at the different reasons that people in the Southeast are using prescribed fire, main reasons there come down to habitat management, fuel reduction, reduce that risk of wildfire, and managing other plant species. We also asked them, how often are you able to burn, and are you happy with that, basically? Do you agree with the statement, I am able to use prescribed fire as often as I would like? It's an interesting split here. The larger camp is that they generally agree that they're able to use it as often as they would like, but there is a not insignificant group that strongly disagrees that they're unable to use it as often as they would like currently. We asked why they think that they're being prevented from using it as often as they would like. Far and away in the Southeast, folks think smoke management is the main reason preventing them from burning. But another motivating factor for why we want to look at smoke from this action and thinking about it in the future. But those next two kind of top ranked concerns are interesting because they're contrasting. One, excessive precipitation is preventing folks from using fire, and drought conditions. So we have a wide range of interesting climatic and meteorological conditions that could be impacting this. There's a whole host of other reasons as well. And, just kind of think about this when we get to some of the climate projections, because the reasons that folks are citing for, maybe not being able to burn as often as they would like, don't necessarily line up with the main driving factors for why we're going to have fewer days in the future. And so just to give you an idea, seasonality is important when it comes to prescribed fire. Much like, we're talking about agricultural seasons, this is a big deal. There's a time to burn, and what we're showing you here, don't worry too much about the actual grayscale, but the dots on these maps are showing you roughly by season where prescribed fires are occurring in a given year in the Southeast. And so we're seeing that there are fewer prescribed fires happening in those summer months in June, July, August, September. Then there's larger amounts of that burning happening in kind of our winter and definitely spring months, and it's a smaller peak happening again in the later months of the year. I'm just going to skip over this. This just kind of reemphasizes that seasonal kind of pattern in the form of air pollution. So really, this is kind of what I want to make sure we spend a little bit of time on, is how we describe and define a prescribed fire window. What's a good day for burning? And this really comes down to what we define as an acceptable burning condition. And so here, again, this is not my work. This is getting into a little bit more of how the Kupfer study defined their prescribed fire windows and looked into the future to see how many of those we'll have at the end of the century. And the way they kind of define this is using three main and commonly used meteorological variables that define good burning conditions. It comes down to near surface relative humidity, 10-meter wind speed, and near surface temperature. And they kind of did an initial look at what these acceptable ranges would be for burning by talking to regional fire managers and by looking at different published burning plans and manuals. And then they went back and looked through several years of burn permits from Florida and Georgia to help understand how realistic those windows are when folks are actually burning, and help that kind of refine what their windows were. So when it comes to relative humidity, it needs to be above or about 30%. Anything below this is essentially going to get you into kind of that red flag warning zone. Wind speed, they went for a slightly lower range on these speeds than might be accepted in some other places, but looking at about 2¼ to 8 meters per second. And temperature is a little bit harder to kind of nail down, but their main kind of initial assumption was to look above freezing and below 32.5 C, or about 90 degrees Fahrenheit. And like I said, they looked at several years of burn permits to see how often those burns happened under these ranges of conditions. And they figured out that they really kind of need to look at the humidity and the temperature occurring at noon rather than, a maximum temperature. And this is really important when they looked at this statistically downscaled output from global climate models, because a lot of that output comes out as, maximum and minimum temperatures. So they had to do a little bit of math to estimate our noontime temperatures and look at that in the future. And so they used, again, these windows, especially for relative humidity temperature, looking at the noontime, and looked toward the end of the century to see how many days across the year and each month are going to meet these conditions. So what I'm showing you here is kind of that progression, looking at a change from current days or historical to the future. And I'm showing it kind of two different ways. The rectangle is giving us kind of the time frame across all months across the entire region. And green means we have a higher percentage of good burning days, and red means we have a lower percentage of good burning days. And you can see that towards the end of the century, and especially in those summer months, we have a very large reduction in the amount of good burning days. And this is primarily driven by those noontime temperatures. Again, not necessarily what burners are saying is preventing them from burning now. So knowing this, kind of the primer background, I'm going to dive into a little bit of my own research and how we use these projections to think about what burners are concerned about, what they might need, and what they might do if they're faced with fewer good burning days. And then we'll get into some of how we use this in looking at potential smoke impacts in the region. So I touched a little bit on this survey already, but there were a few more questions that we asked, and kind of more specifically, like about climate. Are you concerned about climate change impacting your practices and objectives? Again, an interestingly even split almost in some of these categories. The largest, though, was folks saying that, yeah, probably I'm concerned, I think. And then, secondarily, a large portion of folks are unsure. So there's a lot of room for being able to talk to people using this practice about what could realistically be impacting how they're managing their lands using fire. We also asked when they thought climate change might impact their burning practices. And this was also an interesting split, not as even, but the majority, again here, are unsure. So there's a lot of room for this communication and discussion to figure out what really might be and when things might be impacting folks. And then secondarily, though, very close behind, people think that they are currently affected by climate change and how often they can use fire. And this was kind of a main question we really wanted to ask because we used it in our modeling scenarios. We asked, if you were faced with this reduction of good burning days in the future, how would this change your burning operations? The majority of folks said that they're going to try to consolidate their burning, or they're going to try and burn more acres on the days that are available. But secondarily, we see here that folks are recognizing that they're probably just not going to be able to burn as often, and that might either be a full kind of reduction in how they're managing their land, they're just going to burn less, or they might burn or use other non-burning methods like thinning, mowing, mastication to reduce some of these fuels and other plant species. We also asked what would be most important to help them meet their objectives in a changing climate. Wanted to list the top 4 here because they're relatively close, and also things that we hear about all the time, especially when it comes to fire and other practices. But we need more people to help them meet these burning goals. We need more equipment. They would also like some more information about how this is going to impact them and what their options are. And obviously we can always use more and more stable funding to meet these goals. I also wanted to note that there were some write-ins for air quality and smoke and related to both public and government acceptance of this practice and the smoke that's produced. Not an insignificant thing to mention there. There were definitely mentions of need for better liability insurance, which is a big deal, and some notable write-ins. Again, getting back to who's using this fire, thinking about climate, some folks were saying that because we only burn a couple days of the year, climate change is not going to really impact what I'm doing. And in a similar vein, a changing climate doesn't necessarily change the resources I need. Maybe this expands the importance of them, but it doesn't change the actual resources. And finally, just the information that they would like. Obviously, wouldn't we all like to know more about timing and location of impacts? That's kind of why we're all here, maybe more in a shorter term, but we're all here looking at some projections. They'd love to know more about their options in terms of adapting to this climate future. And I liked that I threw this in mostly as to see who would agree with this. And I was happy to see that there were a fair amount of people who said that they would be excited to talk about this with regional scientists who understand their management goals. So just wanted to throw that in there because I thought that was a great thing. And so finally, knowing what we know about these projections, knowing about how burners would respond to potentially fewer good burning days in the future, we use this to model a couple of smoke scenarios. And so I'll try and cover these as at a kind of a 30,000 foot level, but definitely ask questions later if you have any. So what we did was we kind of started from the answer to this question about, if you're faced with fewer good burning days in the future, how would this change your operations? And what we saw from the answers here were basically 2 scenarios of future prescribed burning activity. One is there's just going to be a reduction in burning. We're calling this RX1. And basically what this means is we modified an emissions data set from relating to prescribed fire activity in the Southeast. We basically just scaled these emissions directly with the change in the number of good burning days across the year. Just a direct kind of percent change scaling there. And the secondary scenario that we saw was that, if folks are able to actually consolidate their burning, let's just assume that they're able to really actually conserve their total area burned across the year. And so in this case, what we did was we scaled the emissions again, but instead of just directly with the change in days, we scaled it based on the distribution of days across the year. And so slight difference. And basically what that does is redistribute, say, some of that burning from summer months into those other seasons where there may be less of a reduction in good burning days. And so again, using those 2 scenarios with these projections that we talked about earlier that are based on wind speed, relative humidity, and temperature. In this case, we just looked at mid-century and we looked at their RCP 8.5 scenario. When we look at this across those seasons projected in the region, red indicates an increase in burning days. Blue indicates a decrease in burning days. Again, like we saw, those big decreases are happening in the summer. There's actually a slight increase potentially there in those winter and some fall months. So applying those to those two different scenarios, like I said, we're scaling the emissions based on these. Just a background, we use this with the CMAC air quality model. This is developed by the EPA, an EPA emissions data set that's based on records of burning provided by states, provided by agencies, provided by satellite information. And in this case, like I said, we're modifying the emissions. We didn't modify the meteorology because we wanted to isolate just this actionable or activity component, though the meteorology would definitely have an impact on some of the air quality factors in the future as well. But just to give you a background on that. So I'm going to skip over the wildfire burned area for now in terms of in the interest of time. But when we look at this projected to mid-century and our two prescribed fire scenarios, that's what I'm showing you here. On average, the fire PM 2.5 from smoke could change in a couple of different ways. So that RX1 scenario, that's where we looked at basically there's going to be a reduction in burning, whether they supplement with other methods or there's just less burning on the whole. But we see how that results is in some slight potential decreases in smoke from prescribed fire in some of the highest burning regions. That's that, you know, Florida into Alabama, Georgia, and over into, but also there's a large swath there that could be relatively unchanged and even slight potential increases in the northern and western parts of the region if we're just following directly the change in good burning days. And in the secondary scenario, that RX2, that's where we conserve burning. So there's no extra burning happening here. It's the same amount of burning, but if we shift the burning out of those, even just those summer months where there's less burning on the whole, we shift those into those other months, that's going to impact air quality by potentially increasing smoke up to about 5% across a lot of the region, which is really interesting. And I didn't go too much into the wildfire side of this, but just for context, this is a completely different projection. You know, these changes in prescribed fire wouldn't necessarily hold a huge candle to potential increases in smoke from wildfire. If we want to go into that later in questions, feel free, but I didn't get too much into that for now. And so, like I said, seasonality is a big part of this. So I just wanted to show you how this breaks down by month and how this differs between those two scenarios. So here you're seeing the change in smoke across the region by month between the two scenarios. So again, decreases in those summer months in the middle, but you can see how those increases on the winter to fall months and even in the spring in prescribed fire scenario are much greater. And that's where we're seeing that impact adding up. Those increases in November and December in that prescribed fire scenario too are actually, you know, upwards of 50% in some cases. So it's a big deal if we try to just shift the burning like that. Again, wildfire is there, but we're going to gloss over that. So bringing this back to what this means, putting this into context in terms of air quality, not just relative, but actual impacts and what this means, especially regulatory wise, because it really does come back to regulations. We're monitoring this for human health. And so you may or may not know that the EPA is currently in the process of revising the air quality standards for PM 2.5, which is what we've mostly talked about here. And right now, the Southeast is in compliance with the standard that exists. Nobody's exceeding this, we're all good. But based on our modeling scenarios, we see one, that the current level of burning could potentially put areas at risk of exceeding a strengthened air quality standard. There's a range that they're considering. And so any of the kind of highlighted pixels in these two figures are places where the annual standard would be exceeded across that range. And you can see that when we remove prescribed fire completely in our modeling scenarios, there's way fewer pixels that are potentially exceeding a revised standard. And secondarily, when we look at these future burning activity scenarios, these could also affect compliance with a range of these standards. And so what I'm trying to highlight in these are really the red pixels where we would see an additional exceedance based on the activity changes. And so this is higher for RX2 than RX1, and again, higher for a potential wildfire scenario, which I didn't touch on too much. But there also could be some slight reductions based on the RX1 scenario, just a few avoided exceedances. Anyway, just putting that back in context. Finally, we'll just sum everything up. Thank you for sticking with me on this whirlwind tour of air quality based on climate projections. But really, what this comes down to, we know that climate change is going to change some of our prescribed fire use in the region based on meteorology alone. And this could not only be a problem for the Southeast, but be potentially problematic for other regions that are trying to use more prescribed fire to reduce wildfire risk. And we know that we define these acceptable conditions. And so if we change them, we could yield more burning days, but we want to be careful in understanding how this is going to impact a lot of things, especially when we think about potentially vulnerable populations and their health impacts. Sorry about the animations here, I should have fixed that. But we also know that burners in the Southeast will try to consolidate their burning, but they recognize that they're likely not going to be able to burn as frequently and will need to adopt other methods potentially. They're concerned about climate change impacting their practices and would like to know more as much as they can, but we also recognize that their resource needs are largely similar regardless of climate change. They need the same things no matter what is happening there. And when we bring this to kind of the air quality impacts, we're seeing that changes in fire activity could affect compliance with air quality standards. And even just the current amount of burning could be problematic, especially because we're revising those standards across the country. And really what this all comes down to is that when we think about the future of prescribed fire and smoke in the Southeast, it's really going to depend on what we deem acceptable or necessary in terms of air quality and the need for fire on the ground. So thanks for sticking with me. I know this was a whirlwind and a slightly different topic than you might be used to, but I appreciate it.
Megan, that was fantastic. Thank you for that whirlwind tour. Can you, you can't see my, oh, there we go. Okay, excellent. Good morning, everybody. Thanks for sticking through with us almost to the top of the hour. We do have a few questions. If you have any questions or even general comments for any of our speakers today, please go ahead and enter it into the question box and we'll get to that. If we don't have time, we'll get to it after the webinar. Just a reminder that a webinar recap as well as the recording will be sent out. It is also posted on the website drought.gov, the U.S. Drought portal, so you'll be able to share it with your networks. Our next webinar will be on October 24th, and we'll be focusing on marine heat waves in the Southeast, which has generated quite a bit of media attention this summer. And then coming up in November, we'll get an update on ENSO and the current El Nino, which we've talked about several times today. And as usual, we welcome any feedback on how to improve this webinar. When you click out, there'll be a quick survey. Go ahead and fill that out if you can and tell us what you want to hear more about. I will say that we've heard from many of you that you wanted to hear more on wildfire. And so Megan, thank you for really setting down the stage with a backdrop in the Southeast and focusing on a certain aspect, prescribed burning and air quality. Really fascinating. I'm going to go ahead and start with our couple of questions. So our first question, Megan, is for you. In your survey polling questions, did you ask them the age of the people who responded? And if so, was there any pattern in terms of how they responded?
That's a great question. In this survey, we really just restricted it to make sure that they were adults. We may have actually asked about age ranges. It's just been a while since I've looked at that, but a lot of the folks who are doing burning have been doing it for a while, and so we, without being able to reference that age range from my results right now, I can just tell you that they're going to be skewing towards a slightly older rather than closer to 18, but I don't want to say too much else without having that right in front of me.
Got it. Thank you. Another question for you regarding guidance for burning. Is there a USDA guide that identifies when burning is the best or unavoidable or an alternative?
That's another great question. And I'm also going to have to kind of defer on this one because I've only been a postdoc working with the USDA for a couple of months. So I'm not entirely sure if they have a guide, but I know a lot of a lot of the way this happens in terms of burning is really at the state and local level. So a lot of guidance is going to come from folks within your own state, within your own region. There's a lot of attention through this at state agencies, but there are also, groups that we call either prescribed burning councils or coalitions, as well as prescribed burn associations, which are more on the local level. So there are definitely guides out there from various groups and agencies. I just can't necessarily speak to the USDA one off the top of my head right now.
That's great, thank you. And I know we have a few folks from USDA on, so if you have anything you'd like for us to share, go ahead and just put it in the question box. Next question is regarding the criteria for the prescribed fire windows. The emphasis was on meteorological conditions. I'm just curious if soil moisture plays a role in terms of criteria for prescribed fire windows. I understand this was beyond the scope of your research, but we talk about soil moisture in the context of this webinar each month. Do you have any insight into that?
Yeah, soil moisture is definitely one of the many factors that are going to affect fire risk and when it's okay to use prescribed fire. And so I think that, like you said, that the climate part of this wasn't necessarily my work, but I think the reason that a lot of the meteorological variables get kind of narrowed down to temperature, relative humidity, and wind speed is that those largely explain a lot of some of those other variables like soil moisture. These three are maybe the more important when it comes to that, but soil moisture definitely plays a role, especially in the Southeast when we're thinking about some of the other things that could be fuels like the duff layer, which is right on top of the soil. That's going to have a huge impact between those two. So it is definitely a factor. It's just maybe explained in a large percentage by some of these three meteorological variables.
Got it, thank you. And I think we have time for one more question. This is about modeling future air quality. So would it be possible to model future air quality difference between prescribed burning on lands that are in maintenance versus other lands, such as conservation lands that have restoration burns or hotter burns, or even other types of burns?
I mean, short answer, I think that's definitely possible. What it really comes down to, though, is having the best data to be able to differentiate that kind of burning. And so that is kind of one of the main things we struggle with, especially in modeling, is the quality of the data you put in is going to affect the quality of your results. And so without knowing exactly where I could get that information, I think it would be tough to try and put together a scenario like that, but that doesn't mean that it's impossible.
Great, thank you. And with that, before we close this webinar, would like to know if any of our speakers have anything else that they would like to add. Megan, Jeff, David, Chris. David, is there anything that you would like to contribute to the audience before we close this out?
Yeah, Meredith, I just typed this in the chat box. I forgot to mention that with El Nino conditions firmly in place, we anticipate the excess rainfall and storminess to begin in the coming weeks. So it's critical that farmers get out in the fields and complete their harvest operations before the soils get too wet and the excess rainfall really hampers them.
Excellent. Okay, with that, on behalf of the National Weather Service, NIDIS, the National Integrated Drought Information System, and the Southeast Regional Climate Center, thanks for joining us, and we look forward to seeing you next month. And many thanks to all of our fantastic presenters, returning and new. Have a wonderful day.